Okay, so I'm not going to cover all these notes. The truth is, these notes come from my Algebra 1 class. I did change to Algebra 2, and these notes in Algebra 1 are 3.3. In this class, Algebra 2, it's 2.3. So we're jumping to section 2.3. Change it to 2.3 if it still says 3.3. And let's go over these class openers. So the answer number 1, all you got to do is do the math on top, do the math on the bottom, and then worry about the division bar or reducing. So we have a 3 over 10, and that's it. That's our answer for number 1. Number 2, negative 2 over 5. That's it. You can't reduce. Number 3, 5 plus 3 is 8. 4 minus 10 is negative 6. And right here we can reduce, so we must reduce, right? You can't divide 8 by 6, but you can reduce both the numerator and the denominator by 2, giving us a final answer of 4 over 3. And the negative sign, you could either put it in the middle, or if you'd like, you could put it up on top. But I would never leave a negative sign in the denominator, right? Either put it on top or in the middle, whatever you want. That's your final answer for number 3. So again, this is from Algebra 1, and I go through this thoroughly in Algebra 1. We're only going to be jumping around. We're going to be jumping around on this video for the sake of time. But if you want to see the whole thing, you could watch the other videos that are uploaded to Edmodo, not my YouTube channel, because it's videos from last year. So let's talk about slope. What's the first thing you think of when you think of slope? Y equals mx plus b. How about non-mathematical, though, like just in everyday world, like slope? What does that mean? Roller coaster? Thought a roller coaster? All right, that's good. Why roller coaster? Because it has its ups and downs, right? Or a mountain, right? Slope is really the steepness. It's a way to measure the steepness. So the way to measure the steepness is described with the fraction, and the fraction is rise over run, okay? And by the way, slope is used or represented with the variable m. Who knows, maybe because of a mountain, I don't know. But they use the variable m to represent slope. And slope is a fraction. The top number is the rise. The bottom number is the run. The top number could rise in a positive sense, or it could drop. It could have a negative rise, which would mean that it's going down instead of up. But we're always going to look at lines. We're always going to have a run that's positive from left to right. Okay? So this is a review of Algebra 1. That's why I'm speeding through it. I hope you guys understand it and keep up with it. So when we think about the rise, especially on an xy plane, the rise is really the difference in the y values, right? Like, let's take a look at an xy plane here. If I told you you're at the y value of 3, and then you go to the y value of 4, so what's the change right there in y from 3 to 4? It's 1, right? So when you're talking about rise, you're really talking about the change in the y values. When you're talking about runs, you're talking about the change in the x values. So down here, let's go over some examples. And what I want you to do, I want to hit pause right now, but I want you to talk to a partner and tell me what the slope is from on this line. And we look at lines from left to right, okay? So from left to right, what's the slope? 4 over 1 is correct, because we look at lines from left to right, kind of reading a sentence from left to right. We look at this dot, and to get to that dot from left to right, you're going to be going up. You're not going to be going down. You're going to be going up, and you go up 1, 2, 3, 4. So the rise is 4, just like Benji said. And you're running only 1 unit. So the slope is up 4 over 1. So everybody put a m equals 4 over 1. 1/3 is the slope of the other one. So from left to right, is it going up or is it going down? It's going up, which means that you're rising in a positive manner. You're going up 1 unit. And you're going over 1, 2, 3, right? So 1/3 is the correct slope right there. So put m equals up 1 over 3. I hope we're starting to get this. Let's go over here. These are both positive slopes because from left to right, they are rising. So if they're going up, it's positive slope, up, positive slope. It doesn't matter where they're at on the plane. If from left to right, they're going up, the slope is positive. Now right here, we have 2 examples of negative slopes. Let's call on somebody at random right here. So the correct slope of this one right here is negative 2, because from left to right, you're not going up. From left to right, you're going down. Now, how many levels do we go down? We go down 1, 2 levels. How many do we go over? We go over 1, 2, 3. So negative 2 over 3 is a slope right there. Everybody write down m equals negative 2 over 3. Has a negative rise because you're going down 2 instead of up 2. and you run 3. You always run to the right. You always look at it from left to right. So let's look at that last one right there. Share with a partner. I want to call on somebody at random. That is correct. -1/7 is the correct slope. From this point to this point, you're not going up, you're going down. How many levels do you actually go down? 1. So that's a -1 as a rise. And you run 1, 2, 3, 4, 5, 6, 7. So the slope is m equals -1/7, -1/7. Okay, let's move on. How about this next part? Just reviewing. I forgot to put the little arrow right there on that one, sorry. But this is an example of a positive slope. It doesn't matter where it's at. It could be up here, could be down here, could be over here. As long as from left to right it's positive, it's going up, that means that it's a positive slope. If from left to right it's going down, then it's a negative slope. We always look at lines the way we read sentences, from left to right, from left to right, okay? Now you could be more specific and give me the actual slope, like right here it's rise 1, run 2, that's a slope of 1/2. This one's down 2/3, that's a slope -2/3, right? Now this is an interesting one. How steep is the floor? How steep is the floor? 0. It's not steep at all. It's the opposite of steep. It's totally flat. So this is an example of a line that has no slope, or slope 0, okay? Now, how steep is the wall if I try to climb the wall? See, okay, that's the degree of the floor and the wall, 90 degrees. But when I talk about steepness, it's so steep that it's undefined. Okay, it's so steep. But when it's vertical, that's when it's undefined, right? Now, let me just think about this. Like, let's say you're at the origin 0, 0, and I tell you, what's the slope 1 as a fraction, 1/1? So it'd be right here, right? So here's the slope 1/1. That's pretty steep. And then what if I told you what's a slope 2? That'd be 2/1. That gets even steeper, up 2/1, right? What if I told you what's the slope 5? That'd be 5/1. Imagine that. 1, 2, 3, 4, 5 up on the y, and then over 1 it'd be up here. So 5. So we have the slope 1, 2, 3, 4, 5, and it's getting steeper and steeper and steeper. Could you guys imagine going up 100 and over 1? That'd be really steep, right? So steep that to your eye it would look like it's vertical. But the idea is this: you could keep getting steeper and steeper and steeper, and as you approach infinity, it's going to be perfectly straight up and down. And that's undefined, when it's perfectly straight up and down. So don't forget about that. Undefined means that it's a vertical line, completely. Okay, if you don't know this formula, you need to memorize it. So memorize it, right? y2 minus y1 over x2 minus x1. So if you were absent today and you wanted to watch the video, I recommend going to Edmodo so you can get the full thing, as opposed to this video, which is just a shorter jumping around version of it. So let's go to these problems where I ask you to find the slope of the line that passes through those 2 points, 3, 2 and 5, 6. Now you could, if you wanted to, graph 3, 2 on an xy plane, like go 3 on the x, 2 on the y, and then go to the other point, 5 on the x, 6 on the y, and then calculate that slope, count, rise, and run. But that's a really bad way to do it, right? It's better to use algebra. It's better to use the slope formula. So if you forgot the slope formula from Algebra 1, let's write it down on each problem that we do. The slope formula is m equals, and it's y2 minus y1 over x2 minus x1, okay? And I use different colors because I always recommend starting with the division bar and the subtractions, and then plugging in your x's and your y's. Now, where are you going to get those x's and y's from? Well, these coordinates are really x and y values. That's what a coordinate is. This is your x, this is your y. This is your x, this is your y. And this is exactly why we want to number them, because if I tell you, like, what's the value of x? Well, you don't know if I'm talking about the 3 or the 5, right? But if you number them, x1, x from your first point, y from your first point, x2, x from your second point, y from your second point, then you could clearly see which one's which. And that's where we get the values from when we calculate the slope formula. So I highly recommend write this formula every time if you haven't memorized it yet. If you already have it memorized, it's all good. You could jump right into this, the division and the subtractions. Now, what is y2? 6. What's y1? What's x2? What's x1? Ta-da. All we got to do is the math. 6 take away 2 is 4. And 5 take away 3 is 2. And the only other thing we could do is reduce, or in this case divide. 4 divided by 2 is 2. But I do recommend keeping it like a fraction since we're dealing with rise over run. Okay? So 2 over 1 is the appropriate slope of the line that passes through this point and this point. If I were to graph these two dots and put a line right through them, it would have the rise 2, run 1. It would be kind of steep going up. Let's move on to the next one. Actually, let's skip around. Let's go to number 3 here. Let's find the slope of this guy. Once again, if you don't have the slope formula memorized, write it down on every problem that you do. M equals y2 minus y1 over x2 minus x1. And of course, label each of your coordinates. This is your x, this is your y, this is your x, this is your y, this is your first point. Let's put 1s. This is your second point. Put 2s. And again, the division bar, the subtractions, that's how I always start my slope formula. And then I plug in my values. So y2, that's 1. y1 is negative 5. x2 is negative 9. And x1 is negative 4. So why do I put these minuses first? That way I clearly see minus minus. If I didn't put these negatives first, I might make the mistake of thinking that it's just 1 minus 5. But it's really a minus minus 5, which means that we have to change it to plus plus. So we really end up with 6 up on top, and on the bottom, negative 9 plus plus 4, that's really a negative 5 on the bottom. So your slope is negative 6 over 5. I would not leave the negative on the bottom. I either put it up on the numerator to show a negative rise, or you could put that negative sign right in between, right where the fraction bar is at. So it's up to you. So I did 2 examples. If you want more examples, you could see all the rest of these by going to my Edmodo class and see the uploaded videos that were from last year. Right now I want to do special cases when you're working out the formula. So if you're working out the formula and you get a 0 on top, the answer is 0, okay? And that makes total sense mathematically. If you end up with this fraction, 0 over 2, 0 divided by 2, it's like, if I have nothing, that's 0. And if I divide nothing by 2, what is it? It's still nothing, right? So 0 divided by anything is still nothing, right? So when your 0's on top, the answer is 0. The M is 0. If you get 0 on the bottom, then the answer is undefined, okay? So maybe you want to jot this down. Underneath, undefined, okay? If the 0's underneath, it's undefined. If you ever end up with something like a number divided by 0, if you try to do 2 divided by 0 on a calculator, it's going to say error. You can't divide by 0. Okay? So whenever your 0's underneath, it's undefined. Now what does that visually mean? That it's perfectly vertical. The line's straight up and down. Okay? It's so steep you can't define it. All right. So let's do a couple of examples right here. Number 1, again, the formula, M equals y2 minus y1 over x2 minus x1. Start with the division and the subtractions always first. Label your coordinates xy, xy. This is your first point. This is your second point. y2 is negative 2. y1 is 5. x2 is negative 3. x1 is negative 3. And of course, the minus minus, we change the plus plus on the denominator. Plus right there, plus right there. So up on top, we end up with a negative 7, and on the bottom, we end up with 0. And like we said, undi. If 0 is underneath, it's undefined. I ran out of space. Undefined. Underneath, undefined. What does that mean visually? It's so steep, you can't define it. It's a line that's perfectly straight up and down, kind of like the wall. You can't climb the wall unless you're Spider-Man. Number 2. Let's do this one. Again, well, hopefully you guys already have it memorized. I'm just going to label it x, y, first point, second point. And the slope formula, you always start with the division and the subtraction symbols, and then plugging in your y2 value, which is 4, y1 value, which is 4, x2, which is negative 3, and x1, which is 3. So up on top, 4 take away 4 is 0. And on the bottom, negative 3 take away 3 is negative 6. 0 divided by any number is still what? 0. So right here, the slope is 0. Now, what does that mean visually? That it's a flat line, kind of like the floor. I mean, if we look back over here on these notes, the m is 0 is a totally flat line. Okay, the slope is 0, flat line. Again, if it's undefined, if you had 0 underneath, it'd be going straight up and down. Okay, you know what? Let's actually reflect on that. If I went to the coordinate negative 3, 5, let me do a quick sketch right here. If I went to the coordinate negative 1, 2, 3, and 5, 1, 2, 3, 4, 5, that's up here. And then if I went to the coordinate negative 3, negative 2, that's perfectly down, whoa, that's perfectly down here, right? So this line is totally vertical, okay? And even if you thought of this slope being rise over run, that also makes total sense because you're going down 7 and you're going running 0, so you don't run at all. It's perfectly vertical, straight up and down. Anyways, I hope this is a good review of slope from Algebra 1. Let's do some homework.